Good day, I'm Francis Alfredano of SBIE 1E, and today we're gonna talk about the integral of a partial fraction. So here's our problem. Engineer Oak wants to determine the amount of electrical line required to connect two street lights on elliptical road using partial fraction. And here's our equation that we're gonna solve. First of all, we're gonna look if this equation satisfies the three conditions. So the first condition is if the equation is a polynomial. So as you can see, this is a polynomial. The second condition is that if the coefficient is positive 1. Here, this is positive 1 and it satisfies the second condition. Third one is if the p of x, the degree of p of x is less than the degree of p of x. So this satisfies all of the condition. So the first thing that we're going to do is we need to factor out the x squared minus 9. So the x squared minus 9 will turn into x plus 3 times x minus 3. So after that, we're gonna copy the numerator, which is the 4x plus 3 over the factored out denominator. We copy that's x plus 3 times x minus 3. And the type of factor for our equation is distinct linear factor. So we're gonna turn this into this form as a sub 1 over x plus 3 plus a sub 2 over x minus 3. Let's copy the 4x plus 3 and this equals now to, we're gonna cross multiply the a sub 1 to x minus 3. So this is going to be a sub 1 times x minus 3 plus cross multiply a sub 2 to x plus 3. So this is going to be a sub 2 times x plus 3. Then we're gonna solve for the value of the constant, which is x minus 3 is equals to 0, which will turn into x is equals to positive 3. So the positive 3, we're gonna substitute it to the value of the x in this equation. So 4 times 3 plus 3 is equals to a sub 1, 3 minus 3 plus a sub 2, 3 plus 3. So let's solve for this. 4 times 3 is equals to 12 plus 3 is equals to 15. Equals to a sub 1, 3 minus 3 is 0 plus a sub 2, 3 plus 3 is equals to 6. Next is 15 is equals to a sub 1 times 0 is 0, so let's cancel this out. Plus a sub 2 times 6 is equals to 6a sub 2. Yan. Then the next thing that we're going to do is let's divide both sides by 6. So 6, cancel 6. So we're gonna left with 15 over 6 is equals to a sub 2. So we can divide this and turn this into its simplest form to 5 over 2. So our a squared, a sub 2 is equals to 5 over 2. Next is we're gonna look for the value of the constant of x plus 3. So x plus 3 is equals to 0. Then turn out x is equals to negative 3. So this negative 3, we're gonna substitute it to the value of the x in here. So substitute for x, we're going to negative 3 plus 3 is equals to a sub 1 negative 3 minus 3 plus a sub 2 negative 3 plus 3. So let's solve for 4 times negative 3 is equals to negative 12. Negative 12 plus 3 is equals to negative 9. Equals to a sub 1 negative 3 minus 3 is equals to a sub 1 negative 6 plus a sub 2 negative 3 plus 3 is equals to 0. So negative 9 is equals to a sub 1 minus times negative 6 is equals to negative 6 a sub 1 plus a sub 2, 0, cancel. So negative 9 is equals to negative 6 a sub 1. We're gonna divide both sides by 6 and cancel negative 6. Cancel both sides, cancel negative 6, and we're gonna left with a sub 1 equals to negative 9 over negative 6. Negative 9 over negative 6, we can turn this into its simplest form, which you can consider as 3 over 2 is equals to a sub 1. So our a sub 1 is 3 over 2. We're gonna use the integration by partial fraction formula. So here it is, and we're gonna substitute the values that we've got. So our p of x is equals to 4x plus 3 over our p of x is x squared minus 9 equals to our a sub 1 is 3 over 2 integral of p of x over our, it's gonna put this here, x plus 3 plus our a sub 2 is equals to 5 over 2. 5 over 2 integral of p of x, x minus 3. Next, we're gonna apply the natural logarithm of integration. So 3 over 2 ln absolute value of x plus 3 plus 5 over 2 absolute value of x minus 3 plus c. Next, so we're gonna copy this equals to 3 over 2 ln gonna put bracket kasi if we need to factor the 5 over 2. So ln absolute value of x plus 3 plus, so after factoring 5 over 2, we're gonna left with only 5. 5 ln absolute value of x minus 3 bracket plus c. So next is, let's copy this, 3 over 2 bracket ln absolute value of x plus 3 times x minus 3. So your R5, we're gonna make it as an exponent through power rule. So bracket plus c. Next is 3 ln square root of x plus 3 times x minus 3 to the 5th power plus c. So here's our answer. 3 ln square root of x plus 3 times x minus 3 to the 5th power plus c. So this is our answer for the amount of electrical line required to connect the two street lights on elliptical road. And that's all. Thank you.